Good evening, children. Hope you all are fine. Once again, welcome to A class of GPS. Uh, in my first class, I have already taught about relations, the types of relations, and all about relations. And one exercise also we have completed, 1.2. So today we are going to start the next, that is functions. So let us start with function. So today these are the concepts, the subtopics that I am going to teach you. There will be two parts, two videos, part 1 and part 2. Part 1, first introduction, then types of functions, examples, then exercise from NCERT 1.2. Okay, so after this video, then you have to complete this exercise. I will give you time. Then we will move to part 2. Okay, composite functions, invertible functions, theorems based on invertible functions, examples, then exercise 1.2. Then the chapter 1 will be over by today. Okay, so let us start. Let me start with function. Function, see, it's just like a relation. Only one difference is there. Function is a special kind of relation. So it's nothing but relation, but all the relations are not functions, but all the functions are relations. It's a special kind of relations. So in what way it is different? Let us take a set A, another set B. It contains the elements A, B, C, D, and here 1, 2, 3, 4. Okay, so these are the elements belong to set A and these are the elements belong to set B. Now, through some rule, if all the elements of set A are connected with set B through any rule F. Okay, so F is the rule associates with the elements of A and B. That means this is the input, and through the rule we are getting the output. So this is called as domain of the function, and this is the codomain, or you can call it as range, or you can call it as image. Okay, so this is a simple idea about function. Let us define it. Let us define function. If A and B, hello, are to non-empty sets, then the function from the function f from A to B is defined as f A to B such that for all x belongs to A, for all x belongs to A, there exists a unique image in B. So A and B are two non-empty sets. The function f is defined as a function from A to B such that for all x belongs to A, there exists a unique image in B. That means what are the elements in set A? All the elements must have a unique image. Unique means all the images have at least and at most only one image. All the elements must have one image, not more than one. That means uh, two elements can have one image, but one element cannot have two images. For example, here -1 and 1. Here I have written 1. Okay, so this is set A and this is set B, and the function f of x is equal to x square. Okay, so here -1, square of -1 is 1 and square of 1 is 1. So it's a many one relation which is also a function. But here you see -1 has only one image, +1 has only one image, means they must have unique image. But 1 -1 and 1, if this type of relations are there, which is called as one many relation, this is not a function. Why? Because the element in A doesn't have unique image in set B. Okay, so this is the function. Next, types of functions. There are three types of functions. One is one, next onto, and 1 and 1 and onto. Okay, this 1 or this is called as injective, this is surjective, and this is bijective. Okay, injective, surjective and bijective. So first of all, let us discuss about 1 function. A function f A to B is said to be 1 when for all the elements of x in A, f of x is equal to y, or f of x1 is equal to f of x2 implies x1 is equal to x2. This is 1 1 function. Okay, so each element has only one image. One element in set A has one image in set B. But remember one thing, set B there may be some elements which are not the image of some or the other element in set A, but it can be 1 1. For example, one, 3, 5, 7. Okay. Here I have drawn the map of a function. Okay, A to B is defined as f of x is equal to 2x plus 2. So 2x plus 2 when x is 1, 2 1 2 2 plus 2 4, and 3 when x is 3 it is 8, when x is 5 it is 12, and when x is 7 it is 16. Here you see there are 4 elements, and for each element in set A there is one and only one image in set B. So this is an example of 1 1 relation. Another example, 3 5 7, and this is 9 49 and 25. F of x is equal to x square. Okay, so this is also an example of 1 1, sorry, not relation, 1 1 function. Okay, now here you see these two examples. This is 1 1 function and this is also 1 1 function. Can you see what is the difference between these two? Both are the examples of 1 1 function. The difference is that you see there is an element 5 in set B which is not related to, or which is not an image of any element in set A. Okay, so 5 is not an image, but it is immaterial. You just focus on set A. What are the elements in set A? They must have 1 1 image. For each element 1 1 image. Okay, so there may or may not be any extra element in B which is not an image. It's not, it doesn't matter. However, it is 1 1 function. Okay, so this is the example of 1 1 function. Let us take an example. F of x is equal to x square. F is a function from A to B defined by f of x is equal to x square. Okay, if A to B it's okay, but same problem, let it be n to n, means f is a function from the set of natural numbers to the set of natural numbers, same defined by f of x is equal to x square. These two, now let us discuss about these two cases. Okay, So here A, B, it is not written anything, whether it is set of natural numbers or whatever it may be. If it is mentioned R, set of real numbers. So set of real numbers when it is written, then let us check whether it is 1 1 or not. Minus 1 1, 2 4, or 3 9. Okay, so this is f of x is equal to x square a b. Okay, if it is written minus 1, then relate the corresponding elements. This is 9, 2 2 4, and minus 1 2 1. Okay, so this is a 1 1 relation, 1 1 relation, and it's a relation with a definition, with the rule f of x is equal to x square. So this is an example of a function from real number set to real number. Now let us check for natural number whether it is 1 1 or not. F of x is equal to x square. So here natural number, 1 I can write here 1, 2 4, 3 9. So whatever the natural numbers I am taking here in set A, and I will find out the square of it, then the square must be in set B. Okay, so if A is a natural number, then its square is also a natural number. Okay, so this is also an example of 1 1. But here if I will write minus 1, okay, because f of minus 1 is equal to 1, f of 1 is equal to 1. Okay, so f of minus 1 is equal to f of 1 is equal to 1. Okay, so here this is the set of natural numbers. As I have told you, here 1 1, okay, because each element has 1 1 image. Minus 1 has 1 image, but 1 has 1 image. So it's, at first I have written it is 1 1 relation, but it is not a 1 1 function. How? Because f of minus 1 is equal to f of 1 is equal to 1. That means for minus 1 it is 1, for 1 also it is 1. So this is a many one function. 1 1 image is there, but it's a many one function. Okay, once again I am repeating this one. In the set of natural numbers, this is true because A only natural numbers you have taken, minus there is no chance of taking 1. But in case of real numbers, f of minus 1 is equal to 1, as f of x is equal to x square, f of 1 is equal to 1. So f of minus 1 is equal to f of 1 is equal to 1. Okay, so this is not 1 1. Okay, this is many 1. But in case of natural number, it is 1 1. So this is important. The function it is a function from set of which number to which number. Okay, it's real to real or natural to natural or natural to real or integer to integer, that depends. Okay, so this is about 1 function. Now coming over to onto or called as surjective. A function f a to b is said to be surjective if for all y is equal to f of x, means for each element in B. Okay, each element in B must be an image of any element in set A. Okay, so each element in B must be an image of any element in set A. Just see, injective, each element in set A has one image in set B, but onto every element in set B must be an image of any element in set A. One, two, three, four, A, B, C, D, P. Here I have to taken two examples. Here you see there are 5 elements in set B, A, B, P, C, D, where A, P, C, D are the images of the elements in set A. But there is an element B, which is not an image. Hence, this is not onto. Okay, I said that each element in B must be an image. So B is not an image, hence it is not an onto. This is onto. Okay, this is onto, because there are two elements and each element is an image of some or other element in B. This is called as onto. Okay, one example. F, a relation from R to R, defined by f of x is equal to 1 by x. Okay, so f of x is equal to 1 by x, and this is a set of real numbers. Okay, so 1 by x. Now we have to check whether 1 by x is an image in set R or not. Okay, so if 1 by x is equal to y, then f of x is equal to 1 by x, that is 1 by y. Okay, if 1 by x is equal to y you have taken, or x is equal to 1 by y, so 1 by y is equal to y. Okay, so when 1 by x will take, okay, in set B 1 by x is an element, then there exists y and which must be there in set A, because when x and y belongs to R, 1 by x belongs to R, then x also belongs to R. That means if this is A, set A, and this is set B, not set A exactly, this is R to R. Okay, suppose we will take 1 by 2. 1 by 2. So if this is 1 by 2, then this is an image of 2y. Okay, so 1 by 2 is the image of 2 and 2 belongs to R. If I will take minus 2 by 3, minus 2 by 3, so minus 2 by 3, minus 2 by 3, this is 1 by x is equal to minus 1 by x, this one na, f of x is equal to 1 by x, so 1 by x is equal to minus 2 by 3, then x is equal to minus 3 by 2. That means minus 2 by 3 is the image of minus 3 by 2. And here you see minus 3 by 2, whether it is a real number or not. Real number, hence this is onto. So whatever the numbers I will take in R, in the real number set, whatever the numbers I will take, it must be an image in this set. Okay, this is called as onto or surjective. Understood? Now bijective, 1 1 and onto, 1 1 and onto. Let us, a function f is said to be 1 1 and onto if it is both 1 1 and onto. Okay, both 1 1 and onto means the examples are like this. Let us take f of f is a function from R to R, okay, defined by f of x is equal to 2x plus 1. Okay. Without mapping, let us find out 1 1 and onto. Now f of x is equal to 2x plus 1 for 1 1, whether it is 1 1 or not, let us check it. Let us take f of x1 is equal to f of x2. See, here I have defined 1 1 injective as f of x1 is equal to f of x2 implies x1 is equal to x2, then it is 1 1 or injective. So let us take f of x1 and f of x2. f of x1, it is 2x1 plus 1, this is 2x2 plus 1. This implies 2x1 is equal to 2x2. That implies x1 is equal to x2. Okay, so f of x1 is equal to f of x2 implies x1 is equal to x2. So for each element x1 there is an image x2. This is 1 1. Okay, now for onto, you just check 2x plus 1 is equal to y. F of x means y. So here x is equal to y minus 1 by 2. Okay, so here what is y? Now y is the image. Y is the image. So this is the image of x. And what is x here? X is y minus 1 by 2. So y whatever you take in the set of real numbers. Okay, real numbers, any natural number or integer, whatever you take in place of y, then the result what it comes, it must be there in x. So it is onto. So here while writing onto, you have to just logically you have to write that x is equal to this one. So if y belongs to r, then y minus 1 by 2 also belongs to r, because if y is a real number, y minus 1 is also a real number, and y minus 1 by 2 is also a real number. Okay, so this is onto. Okay, so this is 1 1 and onto, or it is called as bijective, because it is both injective and surjective, hence it is called as bijective. Generally bijective functions are like this. Here this is not bijective, not bijective, because this is onto, this is onto, as all the elements are the image of the elements of set A, so it is onto, but not 1 1, not 1 1, because here this element and this element, both the elements have one image. Okay, hence it is not 1 1 but onto. Okay, so to be bijective it must be both 1 1 and onto, hence it is not bijective. But in this case this is 1 1 and onto, hence it is a bijective function. Okay, so this is all about the types of function: 1 1, onto, 1 1 and onto. Now particularly always you have to check, the question will be given, a function will be given, and it will be asked to find out whether it is 1 1 or onto, or whether it is surjective or injective or bijective. Means you have to check the injectivity, surjectivity and bijectivity of a function. In that case, always for 1 1 relation you have to take like this: one function will be given, the definition of function will be given, you will take f of x1 is equal to f of x2, and through solution you will show that x1 is equal to x2, then it will be on 1 1. And for onto, always think that for onto you think about the image. Okay, so you take an example, means if it is a set of real numbers, you take any real number, then you check whether that real number can be an image of this through the given rule, then it is onto. So generally for onto you have to take the examples. If it is given the set of natural numbers to natural numbers, then you have to take an example of natural number in this set, and you will see whether that is an image of any element in A or not. Okay. Now let us check how well you understood. Let us take an example. This is from NCERT. NCERT exercise 1.2. It is asked that f is a function from R to R, and given that f of x is equal to greatest integer function of x. This is called as greatest integer function. Okay, let us check for its injectivity and surjectivity or bijectivity. Okay, in this case you cannot take f of x1 is equal to f of x2, because the greatest integer function, you can find the value of a greatest integer function unless you know the value of x. For example, 1.2, its greatest integer value is 1. Okay, 1.9, its greatest integer value is 1. So here what happens, f of 1.2 is equal to f of 1.9 is equal to 1, but 1.2 not equal to 1.9. Okay, hence it is not 1 1, because two elements have one image, hence it is not 1 1, it's many 1. Okay, for surjectivity, this is injectivity, so this is not injective, not 1 1. For surjectivity you have to check whether this is, and since it is given R to R, if x greatest integer value of x is a real number, okay, whether it is 2.9, okay, suppose this f of x is equal to given 2. Okay, let us check whether it is surjectivity or not. 2 can be 2 can be the image, of 2.1, 2.5, 2.7, 2.8, like that. So for all these, greatest integer value is 2. Okay, so 2 is the image of these three. That means it is many 1. As you have seen, this is not 1. Now I will take f of x is equal to 1.2, let us take. Okay, 1.2. Since f of x or y, f of x is equal to this is a function from R to R, R to R, R to R. So since this is a set of real number, so there is a chance that there must be a number 1.2, but this 1.2 cannot be 1.2 cannot be the image, because this greatest integer function, the greatest integer value, it is an integer. Okay, the greatest integer value is always an integer. So 1.2 is not an integer. Hence, if this is a function from R to R and 1.2 is a real number, so there is a chance that 1.2 is an element in this set, but that cannot be the image, as 1.2 does not belong to the integer, hence it is not 1, 2. Okay, so it is neither injective nor surjective. This is the example. After this, now I am going to give you the exercise 1.2. You solve it. Very few questions are there. Okay, I am giving time. Then I will play part 2, composite function and invertible function. Okay.